So we're going to focus on slope of a line. Slope of a line is the ratio of a line's vertical change over its horizontal change. How much does it go up or down compared to how much does it move left or right? Okay? Rise over the run. Rise over the run. All right? So with a slope, generally we take 2 points on that line and we find the change in the y's and the x values of those 2 points. Now, which one is which one's the first point, which one's the second point, doesn't matter so much as long as you are consistent. Okay? Notice how that is the same point, y2 and x2. That's the same point. Okay? y1 and x1 above each other. Those are the same point. You don't want to mix and match. So you need to be consistent. But which one is point 1 and which one is point 2 is 100% arbitrary. Makes no difference. You'll get the same answer. Alright? So that's our formula for slope. Alright? So we've got some points here. Alright? Let's find our slope and let's graph our line. Alright? So y2 minus y1 over x2 minus x1. Alright? I have the point 4, negative 3, and I have the point 2, 2. Which one do we want to be point 1, and which one do we want to be point 2? Doesn't matter which one's which, just pick. So it's going to be point 1 or 2? Point 1? Cool. Alright, point 2 and point 1. Why are you not writing? Right, there we go. Okay, so just define which one's going to be point 1 and which one's going to be point 2. That way you're consistent. Again, doesn't matter which one's which, just pick one. Okay, so y2 and x2, that's going to be point number 2. Okay, so I have 2 and 2. Alright, that's point number 2. y2 and x2. Alright, minus y1. What's the y value of point 1? What is the x value of point 1? 4. Okay? What is 2 minus negative 3? 5. What is 2 minus 4? Negative 2. Okay? So I have 5, negative 2. 5 over negative 2 is my slope. Slope we leave as a fraction, like 99 times out of 100. Okay? Can you write as a decimal? Yes. But it makes it more difficult to kind of visualize what the slope is, what the rise over the run is, okay, if we have it in decimal notation, all right? So we leave as a fraction, but always simplify your fractions. Always simplify your fractions. Always, 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 always simplify your fractions, okay? All right, so there's my slope. Let's plot these points. So I'm going to plot 4, negative 3. What quadrant is 4, negative 3 located in? 4, negative 3 is located in which quadrant? 4.
Which one is 4?
This one.
Oh, I was thinking of the opposite. I would have wanted
The x is 4, the y is negative 3. That puts us in quadrant 4. Okay? Point 2, 2 is in quadrant what? 1. Okay? So we have our slope. There's a couple different ways we can write it. Okay? We have that negative sign. We have 5 over negative 2. I could move that negative sign to be the top as well. This is going to be the same as negative 5 over 2. Those are equivalent slopes.
You said 2, 2 is in quadrant 1?
Yes. Those are equivalent slopes. All right? So the top represents our rise, and the bottom represents our run. Okay? So if I have 5, negative 2, 5 means I go up 5 units, and negative 2 means I go which direction? Left. Okay? So if I start down here, I look and I go up 1, 2, 3, 4, 5, left, 2. And we see how that connects those two dots. And I could continue doing this pattern. 1, 2, 3, 4, 5, and then 2 to the left to get my next point. and I have this line. Okay, that's the 5, -2. I could also do it with -5, 2. So if I have a -5, that means I move which direction?
Down.
Down, and then +2 on the bottom to the right. Okay, should we focus on the other now? Not that. Okay, so down 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Okay? So either way, you're going to end up in the same places. So we could track it as up and to the left or down and to the right. Okay? So we're going to have equivalency there. All right? So there's our basic slope given 2 points. Slope formula. All right? I am not ever providing you slope formula. It's something you need to memorize. Okay? Not a hard thing to memorize, but you got to memorize it. All right? Questions, comments, concerns? Good? Okay. All right. Now, slope-intercept form is our most useful, in my opinion, most useful form of a linear equation. It's one we see the most common. It's usually the one that we're most familiar with. Okay? Slope-intercept form. One of the big difference from the Algebra 1 to Algebra 2 is that rarely am I going to give you an equation in slope-intercept form. You're going to need to write it in slope-intercept form. Okay, I'm going to give you an equation either in standard form or point-slope form, and you're going to have to rewrite it into slope-intercept. Okay, but it tells us our slope and our y-intercept. Okay, gives us our slope and our y-intercept. Slope-intercept form is just, hey, y is by itself. Isolate y, get y by itself. And then we have the coefficient of x, represents our slope. And then we have our y-intercept, or the y-value of our y-intercept. And remember, it's always an ordered pair. So if I ask for the y-intercept, don't just give me a number. You have to give me the ordered pair. Okay? Otherwise you will lose points. And that would be sad, because you know the answer. Just make sure you give the whole answer. Alright? So, find the slope and y-intercept of the line. -3x plus y equals -5. What can I do to get y by itself?
Add 3x to the other side.
Good. Okay. Add 3x to both sides. That's going to get rid of it from the left. And y is going to equal a positive, a positive 3x. We don't need that plus sign, but I'm putting it there anyway. Positive 3x minus 5. Okay, so y equals 3x minus 5. Alright, am I in slope-intercept form?
Yes.
Are you sure? Okay. Alright, so looking at this, slope is my coefficient of x. So what's my coefficient? 3. So my slope is 3. Or 3 over 1. Okay, 3 is fine, but 3 over 1 helps us visualize that rise over the run. Okay, it's a rise of 3 over a run of 1. So every point, I'll go up 3, right 1, up 3, right 1, up 3, right 1. Okay, over and over and over throughout my entire line. Slope of 3. Now, think about it for a second before you actually answer. What's my y-intercept? 0, -5. Okay, ordered pair. The y-intercept is not -5. That's the y-value of the y-intercept. Okay, 0, -5 is our y-intercept. All right. Right, you write it down. What are you doing?
I don't know if I so I take a picture so I can write it down. I don't know mine. You want to check my backpack?
I just saw it.
Oh, that's it too. But I never do. I always write everything.
That's on my page.
No, I don't have it.
That's what they tell you in the packet.
Now, what do we do to get y by itself? Subtract 2x. Okay? We want to always get this term by itself first before we do anything else. Okay? So move all the other terms away to the side. So we're going to subtract 2x. It's going to move that term. So negative 6y equals negative 2x plus 12. Okay? Notice. Let me do the highlighter. I cannot tell you how often I see negative disappear after that step. Okay? The minus 6y becomes a negative 6y. Okay? Minus 6y becomes a negative 6y. Now, how do I get y by itself now that it's the only term over here?
Divide negative 6 by everything.
Everything by negative 6. Okay? So, that. So, negative 2 over negative 6. What does that reduce to? 1/3. So, I have 1/3 x. 2 over 6 is 1/3. 12 over negative 6. Negative 2. What's my slope? 1/3. What's my y-intercept? 0, negative 2. Questions, comments? All right. Now let's look at a couple special lines. Okay. Find the slope of the line x equals negative 5. What was special about a line like x equals negative 5?
It's just, yeah.
Well, they're all straight lines. But it's going to be a vertical line. Because x is always negative 5. So, 1, 2, 3, 4, 5. So, x equals negative 5 is going to be that vertical line. Doesn't matter what the y value is, x is always negative 5. Okay? So we need to find the slope of this line. Give me 2 points that are on this line. Any 2 points. Doesn't matter. Negative 5, 1.
Negative 5, 3.
Okay? And negative 5, 3. Okay? Alright? Negative 5, 1, negative 5, 3. Let's find our, what's my slope formula? That's slope-intercept formula. Good. Okay? Which one do we want to be 0.1?
Does it matter?
Nope. Just pick.
Negative 5 in the second.
So do you want the y value of 3 or the y value of 1 to be 0.1?
3.
3 is 0.1 and that one's 0.2. Okay? That's fine. So 0.2, I've got a y value of 1 over an x value of negative 5 minus 0.1 is negative 5, 3. So I've got 3 over negative 5. All right? 1 minus 3 is negative 2. What's negative 5 minus negative 5? 0. What happens when I take a number and divide it by 0? I don't get 0. Undefined. Undefined. So vertical lines have an undefined slope. Okay? Vertical lines have an undefined slope. Alright? Y equals 4. What type of line is that? Horizontal. Okay, so I got y equals 4. Okay, and let's pick any 2 points on that line. Okay, I'm going to do 0, 0, 4, and 1, 4. Okay, same formula. So I got y over x minus y over x. Okay, it's a 0. There we go. Okay, 4 minus 4 is 0, 1 minus 0 is 1. What happens when I divide 0 by a number? 0. So I have a slope of 0. So horizontal lines have a slope of 0. Vertical lines have an undefined slope. Okay? Horizontal lines have a slope of 0. Vertical lines have an undefined slope. Questions, comments, concerns? All right. Maybe later.
What?
Maybe later. Okay? So this breaks down the different types of slopes you'll see. 4 slopes. Okay? First is a positive slope. It's an increasing line from left to right. Okay? From left to right is an increasing line. A decreasing line from left to right is a negative slope. Okay? We always look at these from left to right. Same way that you read, from left to right. Positive goes up, negative goes down. Horizontal is 0, vertical is undefined. All right? Positive, negative, 0, undefined. Now, last thing I want to talk about is our parallel and perpendicular lines. Okay? Special types of lines. Parallel lines, what do parallel lines never do? They never touch. They never intersect. They never intersect. Okay? Parallel lines never intersect. How we know two lines are parallel, other than looking at them, is when we have an equation. We look at the equation, we compare the slope and the y-intercepts. The slopes are the same, but the y-intercepts have to be different. Okay? What if the slopes were the same and the y-intercepts were also the same? It would be the same line. Right? It's everything's the same line. But if we have the same slope and a different y-intercept, well, then we have two very distinct lines that are going to be parallel. They'll never intersect because they have the same rate of change. Perpendicular lines always form a right angle when they intersect. And when we're looking at the equation of perpendicular lines, what we're trying to do is determine the product of their slopes is negative 1. Okay? If we look at the slope of both lines, we multiply those together, we get a product of negative 1, then that means those lines are perpendicular. Okay? The other thing about perpendicular lines is the slopes are opposite reciprocals. They're opposite reciprocals. Okay? One of them is going to be a positive slope. The other is going to be negative. Where you flip the fraction. Okay? So opposite reciprocals. Okay? So for example, if I had a slope of 2, what's the reciprocal of 2? 1/2, and then opposite would be negative. So these would be perpendicular lines. Opposite reciprocal slopes. If I multiply 2 by negative 1/2, I get negative 1. Okay? If I have 3/5, what's the reciprocal of 3/5? 5/3, and then the opposite is negative. And if I multiply these, I get negative 1. Okay, so opposite reciprocals. So let's look at these two equations and determine whether they are parallel or perpendicular or neither. And I want to be very, very clear. When you have this type of question, I need to see the algebraic work that backs it up. Okay? As I've seen in the past, first of all, you could just guess and you've got a 1 out of 3 chance to get it right. That's not going to get you any credit at all. I need to see the work that backs it up. Okay? The algebraic work. So both of these need to be in slope-intercept form before I can compare their slopes. All right? So equation 1, what do I do to get y by itself? Add 5x. That moves it from the left side to the right. Okay, slope-intercept form now?
Y equals 5x minus 6.
Perfect. Equation 2.
Add x on both sides.
Not- Minus x.
Oh, minus x.
Subtract x. 5y equals negative x plus 5. Divide by 5. Y is negative 1/5 x plus 1. Okay? So now, listen to my question. Okay? How do I know if the lines are parallel? What do I look for? What do I look for in the equation? Same slope. Are those slopes the same? No. Okay? Slopes aren't the same, so it's not parallel. Okay? The slopes are not equal. Alright? What do I look for to find perpendicular lines? Opposite reciprocals. So, 5, okay, first slope, what's the reciprocal of 5? 1/5. And then the opposite of 1/5 is negative 1/5. Is that my slope here?
Yeah.
Perpendicular. Okay? You can also double check it. 5 times negative 1/5 equals negative 1. It's perpendicular. Alright? Questions, comments, concerns, queries, or conundrums? I'll leave it there. How do I get where?
So I understand the equation 2 and back to equation 1.
So, I compared the slopes. I have a slope of 5 and a slope of negative 1/5. They're not the same, so it's not parallel. Okay? So now moving on to perpendicular. Perpendicular lines have opposite reciprocal slopes. So I'm looking at my first slope of 5. Okay? The reciprocal of 5 is 1/5. And then the opposite is negative 1/5. So that means, and it's the same as this one. So that means it's perpendicular. I double check it by taking both slopes, multiply them together. I get negative 1. That also means that they're reciprocal, or that they are perpendicular.
Does 1/5 have to be negative every time?
They have to be opposite signs. Because when you look at this, one slope is going to be positive and one's going to be negative.
Okay.
That's the only way you'll get perpendicular,
So-
is if one is
so-
positive and one's negative.
In equation 1, to see if they're perpendicular to each other, 1/5 would have to be it has to be positive. So if it was negative, it wouldn't be perpendicular. But if you got a negative answer.
If equation 1 had a negative slope, they would not be perpendicular. Okay? So one has to be positive and one has to be negative, and they have to be reciprocals.
No, not equation. I meant to say equation 2. My fault.
Yeah. So equation 2 has a negative slope. If it wasn't negative, they wouldn't be perpendicular. Okay? And then parallel has to be the same slope. Any other questions? You sure? Now's a good time if you have a question.
Wait, are you saying that one has to be negative and one has to be positive?
In order to have perpendicular, one slope has to be positive and one has to be negative. That's the only way you're going to get that right angle. Is if you have one going down and one going up. Otherwise, you're never going to get a right angle. Okay? Any other questions?